Hello, and welcome to the True Introduction into Biomedical Engineering. In this chapter, we'll be going over some basics of biomedical engineering, giving you a brief understanding of its introductions and application, as well as history of biomedical engineering, to give you a quick background before we dive into specific concepts. In this section, we're going to be doing an introduction into biomedical engineering, specifically looking at what it is, how it works, and its general relations to the sciences and engineering. So, what is the definition of biomedical engineering? Biomedical engineering is the application of the concepts, knowledge, and methods of different engineering disciplines to solve the healthcare-related problems. Before biomedical engineering was an extremely new development and field, there were mainly three types of engineering fields that did the work of biomedical engineering. You'd have electrical engineering, mechanical engineering, and chemical engineering. Within electrical engineering, you'd be designing circuits and prototypes to see how electricity and different machinery could work with the body, as well as creating different types of prosthetics arms and catheters and other types of electrical related circuitry in order to have applications to the human body. For mechanical engineering, you'd be helping create the machines that are necessary in order to have an impact on human life, such as creating prosthetics that are more of just the mechanical side in order to have them be properly sturdy, withstand force. You'd also be looking at implants in order to create implants that can withstand the forces necessary in order to have that application within the body. And lastly, for chemical engineering, when you're tying these electrical and mechanical parts together, you need to make sure that they're compatible. So you'd be looking at different types of applications of layerings, or the different materials that you're going to be using, or fabrication of new materials entirely, in order to have the proper structure, the proper requirements of that material. If you need it to withstand a certain load, but you need it to be very light, you need to create that type of material. If you need it to be very durable and non-inert, that is what the chemical engineers would be looking at. However, over time and within the past generation, biomedical engineering has really been combined into one singular entity, and that is applying electrical, mechanical, and chemical engineering concepts into one single field. And rather than focusing outwards on for electrical engineering, you'd be looking more at computers, you'd be looking more at creating electrical devices and appliances. For mechanical engineering, you could be creating machinery for rockets and aerospace. In chemical engineering, looking at petroleum, all of the main concepts pertaining to that of just the healthcare industry and health and biomedicine is what biomedical engineering is really looking at. Biomedical engineering also applies technology and engineering in order to benefit the healthcare and medical facilities. As I said, you're combining electrical, mechanical, and chemical engineering concepts into that of focusing on healthcare and medical facilities. You're not really looking at anything outside of that, such as creating automobiles or making street lights or some sort of luminescent devices. You're mainly focusing on healthcare and medical facilities, whether that is medical devices within the field, you're looking at prosthetics, machines to help make researchers and medical professionals' jobs more easier. That is what is biomedical engineering focusing on. It's primarily within the scope of healthcare and medical facilities. That being said, you're also able to look at it from a more computational side as well. Biomedical engineers can also be more focused on looking at the information that is taken from these devices and extracting it from them, which is something that we'll talk about later on when we're looking at the signals and imaging of biomedical engineering within this course. Lastly, biomedical engineering applies different engineering methods to understand, modify, and control biological systems. So the main thing that differentiates someone who's particularly interested in chemistry, biology, nursing, doctors, work, and biomedical engineering is that you're applying the engineering method to everything that you're looking at. whether you're creating a device, whether you're looking at images, generating the images and the signals from these devices, whether you're helping create some sort of prosthetic or a implant to help make a person's life more easier, you're going through the engineering method, where you're trying and testing and organizing and sorting through whatever data and evidence that you have that you've gotten from your experiment to help understand what's going on. And for that thing that you're really hoping to get out of it, you're helping to modify, control, and improve biological systems, either in human beings or in animals. Animals are primarily used as test subjects within the field of biomedical engineering, but humans are the primary goal. We're trying to improve someone's life if they had a catastrophic accident where they are paralyzed or they are not able to move as well as they did due to age restrictions. Biomedical engineering is solely focused on improving the quality of life for everyone around us in order for everyone to have healthy, safe, and enjoyable lives for as long as they're able to live, and focusing on those aspects alone, as well as tackling some of the most difficult challenges that we face, such as incurable diseases, cancer treatment, and other aspects of our lives. And that is mainly the definition of biomedical engineering in the most concise and condensed way I can possibly give it. There's a lot to look at in biomedical engineering, as healthcare is very much changing over the last 100 years. With the introduction of new types of medicine and antibiotics, healthcare has rapidly improved, but there's still a lot that needs to be tackled, and biomedical engineering is integral in helping understand and fix all the conflicts that we have.